Hi students, today I am going to explain periodic classification of elements chapter 5. So we already know what are elements, compounds, mixtures. So matter is composed of elements, compounds and mixture. Elements means having only one type of atoms. Compounds will be having many group of elements which are combined in a different ratio, and mixtures are a group of elements combined. So we know that there are 118 elements around us. So we know only 118 elements. Out of that, 94 are naturally occurring elements. So why we have to arrange these elements in an order? So we are seeing that we are arranging the elements in different orders, and so many trial and errors are made to arrange these elements. First attempt was the earliest attempt to classify the elements are they are grouping them into metals and non-metals. Later are the different many classifications are gone. First is Daubernier triads of elements. So in the year 1817, John Wolfgang Daubernier, he is a German chemist. He arranged the elements in groups according to the similar properties. Triads means three. So he grouped the elements in having three elements, three having the same properties. Triads means three. So he showed that when three elements are arranged in a periodic table, they are written in order of increasing atomic masses. These elements are arranged in the increasing atomic masses, so that the mass of first and the last, if we add it and do average, then we'll get middle element. So the it is not accurate. It is roughly the average of the atomic mass of the first and third element. See here, they gave, for example, lithium, sodium, potassium. The atomic mass of lithium is 6.9 and sodium 23. We should get 23 when we average lithium and potassium. Let's check that. And potassium atomic mass is 39. So we added 6.9 lithium's atomic mass and 39.0 potassium's and did average. We got approximately 22.5. It is near to 23. So like that, Daubernier triads arranged the triads in the increasing atomic masses, and further he cannot continue this because these elements are arranged downwards in order of increasing atomic masses. After that, it did not work out. So Daubernier triads was successful only with these three triads only: lithium, sodium, potassium, calcium, strontium, barium, chlorine, bromine, iodine. Further, it was not useful, so it was not considered. After that, next by Newland's law of octaves. So after the attempt of Daubernier, so again with the increasing atomic masses, John Newland, an English scientist, arranged the elements. He started with the very lowest atomic mass, hydrogen, and ended with thorium, which has 56th element. So his law is called law of octaves because he told that every eighth element will be having the similar property as the first element. So in Newland octaves, the properties of lithium and sodium were found to be same because it is the eighth element after the lithium. So beryllium, magnesium resemble each other because it is a eighth element will be the repetition of the first element. So it is like music, sa, ri, ga, ma, pa, da, ni, sa. Again the sa will be same, the eighth notion. So see here, sa, ri, ga, ma, pa, da, ni, sa is the again repetition of the first. Like that, every eighth note is similar to the first one. So like that, he arranged the elements like notes of music. So he found that the law of octaves was only applicable up to calcium. It was okay. First element was similar to the first element's properties are similar to the every eighth element. After that, it did not work out. It was assumed Newlands that only 56 elements are existed in nature, but we already know that more than these are there in our nature. But later several new elements were discovered and their properties are not fitted to the law of octaves. So Newlands adjusted 2 elements in the same slot, but unlike elements under the same slot, so we can see that this Newlands law of octaves did not work out after calcium. So this also became irrelevant, like Daubernier law of triads. So the Newlands law of octaves worked only with the light elements only.